Yes.
Just before we start, I have to take the mic. Yeah. Before starting, update regarding arrangement of papers and the submittal time.
Well, so far we didn't receive anything from the university, Nasser. When
I have a proposal.
This to be communicated to the university or?
No, not to you, Doctor.
Okay.
Request. Proposal and request at the same time.
Go ahead. Okay.
We make the projects, the grading for the paper only on the project. It means on the technical case and on the AI, because this is, we have to have a case study and then we have to do it by AI. And then we will try to do the basic of the report just. And then after 2 months, then we will give you the papers after the term. So the grading will be based on the case study as a technical as well as AI. Because we have shortage time. Before we have a plan, we are working, for example, talk about our group, we are concentrating the technical studies, the technical case, the coding, and we are doing good progress. Then we have now around 50 days to the end of the semester to do this one. Suddenly we have only 20 days to start the finals. So
that your proposal is giving IC grade until you finish after the term.
No, but all the grade based on the technical case of the report itself, the case, the coding, the case study, and then the paper will submit it later on to you. So the 40, the grade should be on the.
Are you sure after the term you will submit the paper? Are you sure?
For me, I'm sure, and my group, 100%. We are your student. We will not run away.
Yeah, but when you put something in policy or so, this is should be valid for all.
For me, we did this 2 times in previous, in my master. We always submit the paper in a conference after 6, 7, 8 months. So it's always submitted and reported, and then we record all the participants. Just I did it last semesters in December, and I graduated in May for master, 7 months with Dr. Fahad.
Yeah.
So this is my proposal and a request in the same times. For us, me and our group, we guarantee 100% that we will work in the summer and we will submit it to you.
I'm also quite sure the others also will do the same. All of you are responsible guys. But let me just wait until the university tells us when the exam will start, and if they shift it earlier, or we will see later يا ناصر okay.
Inshallah. Okay. Thank you, Doctor.
So we have a progress report to be submitted this week, suppose week number 11, and the reading assignment final should be delivered on week number 12. So next week you will submit both the progress report and the reading assignment. Okay?
With the presentation, Doctor?
We will schedule the presentation either next Wednesday or we can schedule it later on. ماشي?
Doctor, for the reading assignment, will it be enough to submit the presentation?
We need also to tell us or tell the others also the technique that you work on, so they can get benefit of this as well.
So there will be a presentation, you mean?
For reading assignment, yes, at the time being, yes. Okay. Reading assignment, but maybe it would be on Wednesday coming Wednesday, or we will schedule it later on. Okay?
Okay.
But you submit it by next week, inshallah. Okay.
This means both Wednesday, yeah? This is what you mean, both?
Yes.
Reading and progress report.
Yes.
Okay, clear.
And by the way, we have short quiz today, inshallah, 2 minutes or 3 minutes. Short quiz. Okay, so we discussed the non-dominated sorting genetic algorithm as a true multi-objective optimization technique. There is no aggregation of the optimized objectives. So, and you apply here the dominance concept in the selection process. So the non-dominated solutions are, preferred in selection. So you create what we call the dummy fitness based on the dominance in order to do selection process in genetic algorithm. Okay, so we have two major steps here: fitness assignment and fitness sharing. The idea is to keep the diversity of the Pareto optimal set. So the first step here is to, for non-dominated sorting genetic algorithm, is to do ranking. You rank all the population. This is the first front, second front, third front, fourth front, and so on. And at the beginning, you assume dummy fitness here, and you look at the distribution. You assign sigma share, the neighborhood. You define the neighborhood, and then if you have a crowded area, so many solutions around that solution, so its dummy fitness will be degraded. You select the minimum here, and you subtract epsilon, and then you assign the dummy fitness here to all of those, and then you do sharing. These are very close to each other, so their dummy fitness will be degraded, and you select the minimum value, you subtract epsilon, you assign it here, and you do this for all the solutions. So this is a dummy fitness. So in the selection process of genetic algorithm, when you select two solutions randomly, and which one is better, which one has the fittest or higher fitness, dummy fitness, you will select it as the candidate or the parent for the crossover and the mutation. So this is the fronts. This is the first step, and then you assign the neighborhood, as you mentioned. You measure the distance among all the solutions, and then you compare the distance with the sigma share that you set. And whenever you have sigma or distance less than sigma share, of course, this is a normalized objectives. So if it is less, then you calculate it here. If it is outside the neighborhood, then you put it 0, and you sum them up, and then you can adjust the dummy fitness by the raw fitness over the sharing of the solution. So this is the and then you subtract, and then you go for to the next front, and so on. I hope you know these things are clear, and I'm just highlighting what we have covered earlier. So let us take this example and solve it. You have here one objective x square, and the other objective is x minus 2 square, and you have x varies from -5 to 5. So how to proceed? Assume that you have a number of population equal to 6. So you randomly create the variable x between -5 and 5. Assume that the first one is -1.5, second one, third one, fourth, fifth, and sixth solution. So if you substitute f1 -1.5, so it becomes 2.25, or f2 -1.5 minus 2, so -3.5 square equal to 12.25. And this is for the second solution, you calculate f1 and f2. For all the solutions, you calculate f1 and f2. Now we need to develop the dummy fitness for all the solutions. These are the objectives, but we need the dummy fitness based on which we will do the selection process. Of course, you can, what you can do, you can, represent this in F1, F2 frame. You have here F1, F2, and then you allocate this 2.25. So this is here, 12.25. So this is, the solution is here. So this is X1. You plot X2, you plot X3, X4, and so on. You distribute the solutions as here. Of course, you can do ranking. Now this would be the first front, second front, third front, and then you can assign the row fitness and check the distance among the first front, and then you can proceed. So this is the solution. Now let us remove this. These are the solutions that we have. Okay. So this is solution number 1, solution number 2, 3, 4, 5, 6. You have it here. Okay. So what we will do is, this is the first front. Of course, definitely you can see that this is the first front, this is the second front, and this is the third front. So let us start with this front. Let us assign a value of this front here. So assume that the row fitness, of course, this is the ranking. You have 2, 4, 5 in the first front, 2, 4, 5. Second front is 1 and 3. Second front. Third front is number 6. Okay, so let us start with the first front. First front here, we will assign a dummy fitness equal to 6. There is no magic behind 6. 6 is simply the population size. You can set it any value, 100, 200, 300, 10, whatever. Yani, this is a dummy fitness. So let us assume it's 6. So the solution in the first front will be given 6 at the first trial here. Okay, so next, what we will do is to do sharing. We need to do sharing among these solutions in the first front. So it seems, as you can see here, in the 4 and the 5 are very close to each other. So assume that we will do sharing here, and the function or the row fitness here given to 4 and 5, which is 6, is degraded. Then the 4 and 5, M5 will be greater than 1, M4 will be greater than 1. And the distance here below sigma share. You can assume sigma share and so on. And this is just the You can set the sigma share as we mentioned earlier. You can measure the worst, maximum, minimum of the objectives, and then you can divide this by 10 or 20 or whatever to define the neighborhood. Okay, so the dummy fitness will be degraded here for 4 and 5. So 4 and 5 becomes 3.43 after dividing 6 over M5. And this comes from 6 over M5 and 6 over M4. Since they are, we have only 2 solutions. So in this case, you have similar fitness here. Type, okay, so this is the first front. So let us go to the second front. Alas, the first front now, dummy fitness is 6, 3.43 and 3.43. So let us go to the second front. What is the minimum that we have here? For the first front, what is the minimum fitness? This is the minimum fitness.
3.44.
So in this case, what we will do, we subtract epsilon from here. So let us start the second front by 3 مثلا. طبعا الابسلون is just any positive number. يعني this is a dummy fitness. And احنا at the end we will compare. احنا we need something below this. يعني 3 is okay, 2 is okay, 1 is okay, 1.5 is any number. Yeah. So this is 3, and we will start the dummy fitness of front 2. This solution and this solution we will be given 3 at the beginning. And then we will do sharing. We will search for crowded area. It seems in 1 and 3 are very far from each other. Am I right? That means in the M3 equal to 1, M1 equal to 1. So that means 3 will be given for 1 and 3 as well. Type. Next step, we will go to the second front, but we will divide or we will subtract epsilon from 3. Let us assume that third front, the dummy fitness equal to 2. We have only one solution, but this will be kept as 2. طبعا M6 equal to 1. And there is no sharing here or no other solution in the front. So this is the 2, 4, 5 first front. 4 and 5 are very close, sharing greater than 1, so it becomes this value. And solution 1 and 3 in the second front, they are, you subtract epsilon from 3.43. So you will start 1 and 3 will be given as 3. Since 1 and 3 are very far, so they will be kept as 3. Solution 6 in the third front has a fitness less than, this is than any other solution in the second front epsilon, subtract epsilon, so this becomes 2. And as you can see here, we start with 3 and 3, and later this will be given as 2. Okay, is it clear the process? Is it clear?
Yes.
Okay. So this is the flow chart. You initialize the population, the Pareto set. At the beginning, you put it empty set. And generation counter, number of maximum number of generation, and so on, population size, everything. And you start ranking process. So F1, this is assume this is the front counter. So you start with counter 1 here. And the population, you search for the non-dominated solution. This will be in the first front. All the population ranked. If no, then you identify the non-dominated solution and you assign dummy fitness, which is raw fitness. And then you do the sharing in the current front, and you adjust the dummy fitness accordingly. And then you add the front, go to the second front, and so on. So you exclude the first front from the population, and you search for the other non-dominated solution, and you repeat this until all the population is ranked. What is the maximum number of ranking that we have? What do you think? What is the maximum number of ranking? What is the maximum number of fronts?
The number of
Number of solutions.
Number of solutions. Yes, number of solutions. This is of course extreme case, and you have these are the population. This cover all, this cover all, this cover all, and so on. So this is the front 1, 2, 3. So if all the solutions are ranked, if yes, then you start the technique, select according to dummy fitness. You do selection according to the dummy fitness, which is calculated here. And then you do crossover and mutation as regular. Plus you have now the 2 parents, and then you can do the crossover and the mutation. And all the, did you generate the N solutions, the population size? Did you fill all the population size? If yes, that's okay, خلاص, you can go forward. If no, then you can select another 2 parents, you do crossover, you have 2 solutions, and you repeat here until, if no, then you can go back and forth to select and do crossover and mutation until you have all the new population here. If yes, خلاص, you can go and check the stopping criteria. Otherwise, you can go forward. If the stopping criteria is met, then you can select the best compromise solution. The output here will be the Pareto set and the best compromise solution, and then you can stop. If the still the stopping criteria has not been met yet, so we can go to another generation and update the Pareto set. Of course, the non-dominated solution here, which is the first front, will be coupled to the Pareto set. And these are the Pareto solutions. By the way, as we mentioned, the non-dominated solution you have here, this is the population. Okay, let us say this is the population. These are non-dominated solutions at the time being. When you do crossover mutation, when you have another generation, these solutions will be, you will have better solutions and so on. So these are non-dominated solutions. When you end the search and you have this, at the end, we call this as a Pareto. And these are non-dominated. But when you finish the search, this becomes the Pareto. And this is, we can say, this is the best among all the feasible or all the search space. So this is, we call it Pareto set. So we have the non-dominated solution on the first front coupled in the update Pareto set here. And then you can, Pareto set size is greater than the maximum. If yes, then you do clustering. If no, you can go back and you have now new population. You repeat this front number 1 and do ranking again and again and do this. So if yes, then we do reduce by clustering, and then you go back to here. Otherwise, if no, we go directly to this. Any question, Nasser, please?
Yeah.
Nasser.
What about the normalization?
Yeah, normalization is embedded here. And normalization will be embedded here. You assign a dummy fitness when you do sharing. When you do sharing here, okay? When you do sharing, you need to find Dij. You need to find the distance. Am I right?
Yes.
When you get the distance, you have to normalize the object. And you can say, the square root of J1 of solution number 1 minus J1 of solution number 2 over J1 max minus J1 minimum. So you divide over the whole range. So this is, of course, a square. This is objective number 1. And this will be repeated for the objective number 2, طبعا under the square root, of course. Same as J2. Solution 1 minus J2 of solution 2 over J2 max minus J2 minimum square. So you do normalization here, Nasser, embedded here in the calculating the distance. Is it clear?
Yeah. Okay. Thank you.
So this is the flow chart of the non-dominated sorting genetic algorithm. Any question? So let me ask a question. What do you think is the limitation of non-dominated sorting genetic algorithm? What do you think? The limitation of this method. What do you think? Now we cover the method step by step. So can you just tell us what is the limit? What do you think is the limitation? Then we will discuss now NSGA2, second version of this, which overcomes some of the drawbacks. But what are the drawbacks of NSGA? Muhammad Tahir?
Very complex.
Computational, yes. You need to rank all the solutions, right? And
Yes.
also do sharing, so you calculate the distance.
And the mu, this is difficult to set.
Which mu?
The sharing distance, the neighborhood.
Yes, yeah.
That
This
one I did not honestly get how to set.
Sigma share.
Sigma share, yes.
This
Sorry.
is another drawback. You need to set sigma share, and sigma share is subjective. And you may put it in the wrong way. Maybe sigma share can be set, which can have all the solutions in the same neighborhood, or you cannot. Either you can put it very high or very low. There is no
No typical
clear
value.
guideline or systematic guidelines for the setting of sigma share. And انت سابع now you mentioned computational complexity and also setting of sigma share.
Yes.
طيب, what else, Nasser Hakami? Do you want to add something?
Yes, I think it is time consuming if we have large population, since we need to make a distance clustering many times, and for each front we segregate so looking for the crowded area. If this for 10 solutions, it's complicated. What about if we do it for 500? It will take time.
Yes. So this will be also under the computational complexity of the problem. يعني computational time calculations. So it is computationally expensive. You have to do so many calculations here. Second one is, as we mentioned, in the sigma share setting is not clear. Okay, so there is another drawback. If you can see here, حتى in front of you, there are some. يعني you can infer here or extract here one of the drawbacks. Look at these two solutions. They have the same dummy fitness. These two solutions, you have the same dummy fitness. So if, for example, you select these two for mating, which one you will select?
There is no elitism here, Doctor.
There is no
Elitism.
exactly. You add.
You take elites.
Yes, you add to the drawbacks of NSGA. And this is another drawback. And now we have 4 drawbacks. The first is computationally expensive. Second, sigma share setting is not easy, subjective. The third, and you have here so many solutions, could be the same fitness function. The fourth, as you mentioned, no, there is no elitism. There is no elitism. You cannot here. Of course, it needs to adjust it to also have some kind of elitism. So the best solution is not missed or are not missed in during the crossover and the mutation and so on. So you need to apply also elitism here to improve the solution quickly. So this is 4 limitations of NSGA. NSGA2 will overcome such limitations as we will see here. Okay, so drawbacks of NSGA, you have high computational complexity. NSGA is computationally expensive. Large population size due to non-dominated sorting. You have to rank them all, and then you have to do sharing and so on. Lack of elitism. Elitism can speed up the performance, and again, you keep the good solutions survive to the next generation. You are not missing them. Need for specifying the sharing parameter. Also, this is another problem, to set sigma share as we discussed. So let us move forward. In SGA2, the sharing function is replaced by a crowded comparison approach that eliminates sharing difficulty. For NSGA2, we will do somehow we will do some kind of sharing also, but we will not do sharing for all the solutions in any front. We will limit the sharing process. Okay, we will limit the sharing process here. We will do it in only one front. And we will do sharing in only one front. The others we will not do. The crowding distance approach doesn't require any user-defined parameter. It doesn't need sigma share. For maintaining diversity among the population members, the crowding distance approach has a better computational complexity. As I mentioned, we will not do crowding distance calculation in all fronts, but we will do it in only one front. And we will see which front we will do. Crowding distance calculation. And how to calculate the crowding distance? Assume that we have a certain front as such. How to do crowding distance calculation here? This is a front among others, of course. So the crowding distance computation requires sorting the population according to each objective function value in ascending order of magnitude. And you have here, for example, 6 solutions. This is F1 and this is F2. Can you rank according to F1? Can you rank according to F2? Assume that this is a solution 1, 2, 3, 4, 5, 6. Nasser, do you have a question?
I have answer.
Okay, go ahead.
For F1 from 1 to 6 and for F2 from 6 to 1.
Right, okay, 1, 2, 3, 4, 5, 6. This is the rank according to F1. And we have here 6, 5, 3, 4, 3, 2, 1. Okay, great. So you rank the solutions in a certain front according to F1 and F2. Definitely, when you have multi-objective optimization or when you applied such techniques, most likely the objectives are conflicting. You have conflicting objectives. So if you rank from 1 to 6, then this will be from 6 to 1. And no, they are conflicting. The best one here is the worst here. Okay? The best one here is the worst here, and so on. So this is the ranking according to each objective. Okay. Second, for each objective function, the boundary solutions with the smallest and largest values are assigned an infinite distance value. Keep in your mind, we need one of the objective of the multi-objective optimization is to keep the diversity of the solutions. So these solutions are very important, 1 and 6. So the distance, the crowding distance of D1 equal to D6 equal to infinity. We assign them very high value. Then we need to keep these solutions in the population to keep the diversity. So these solutions will be given infinite number here or very high number of distance here. You assume that the distance is very high. What about the intermediate solutions? Now, these solutions, we need to classify them according to the crowding distance, 2, 3, 4, 5. So we will see how to do this. All other intermediate solutions are assigned a distance value equal to the absolute normalized difference in the function value of two adjacent solutions. Here we are not, calculating the Euclidean distance, which is the square root of x squared plus y squared, but we can calculate the crowding distance here in very small, very very efficient, very simple way, let us say. Assume that the functions here, f1 and f2 for this solution, f1 and f2 of these solutions, and of course you can normalize all these values. Okay, so these solutions are given, f1 and f2 for each one. Okay. The calculation is continued with other objective functions. Okay, so this is we need to explain step number 3 more. Assume that you have solution number 2. We need to find the sharing or crowding distance of solution number 2. Solution number 2 here is in between 1 and 3. Class 1 is given infinity, 6 is given infinity. 2 between 1 and 3. 2 between 1 and 3. So can we get the distance between 1 and 3? This is the distance in terms of f1. And this is the distance in terms of f2. When we normalize f1 and f2 for each, and assume that this is, for example, just an example. This is normalized, so this is, for example, 0.1 and no, of course, this is the extreme one. So this should be 0 and 1. لأن we need the distance between 0 and 1. Right? So this is the minimum value of f1, so it becomes 0. This is the maximum value of f2, so this becomes 1. For solution number 2, this could be 0.1 and 0.9, مثلا. And this one could be 0.3 and 0.7, مثلا. Just an example. So the distance between the next and the previous solution, 3 and 1, is in terms of f1, it becomes 0.3 plus 0, 0.3 minus 0. So this one is 0.3, and this value is 0.7 minus 1 or 1. Of course, this is a distance 1 minus 0.7, so this is 0.3. Is it clear? Is it clear? Shabab, are you with me?
Yes.
So the sharing distance or crowding distance of solution number 2 is 0.3 plus 0.3. So solution 2 is sharing distance D2 now equal to 0.6. طيب, number 3. What is the sharing distance? Again, sharing distance, we will take 4 and 2. Next and the previous solution. So we will take the distance here between these objectives, normalized form. 0.4 is, for example, 0.5 and 0.5. Assume, so this one becomes 0.5 minus 0.1. So this becomes 0.4, and this one is 0.5, 0.9, so it's 0.4. So D3 is 0.8 in this case. But it's not necessarily to have 0.3 and 0.3, or 0.4 and 0.4. This is just by sudden. It is not necessary to have same values. D4, we need also D4. You can have D4 between 5 and 3. D5 between 6 and 4. And you can get D4 and D5. And you can look at those and see which one will be selected. Which one is better? Let us forget about the selection now. But which one is better? with the minimum distance or with the highest distance? If this is 0.3, if this is, for example, 0.4, if this is 0.5. Can you order this solution 2, 3, 4, 5, اللي هي intermediate solution here, according to the distance from the better to the worst, or from the best to the worst? Which one is the best solution here? Which one is the best? Nasser.
The one with the longest.
The one with the longest distance, that means there is no solutions nearby. So this will be number 3, which is the best one. Then you have number 2, solution number 2. Then you have solution number 5. Then you have solution number 4. So this is the best. This is the best in terms of the intermediate solution here, and this is the worst. Okay. So this is how to calculate the crowding distance. As you can see here, crowding distance is very simple. You just subtract 2 values. Of course, definitely you have the normalized objectives here, and this is the case. So this is a crowding distance for each solution. The boundary solutions are given very high distance here. So in order to keep them, then for example, if I ask you, this front has 6 solutions. I would like to select only 3 solutions. Select 3 solutions in this, from this front. Which are those solutions that you will select? Can you tell us which solutions you will select? Nasser?
I will select the 2 in the extreme and then the one with the longest.
Yes. These will be selected in order to keep the diversity of the solutions. Okay. So these are how to calculate the crowding distance of the solutions in a certain front. Okay. So step number 3, this is for one solution, for one objective, and then you add the other objective here until you finish all the objectives. If you have 3 objectives, so you have, you have 3 values. Let us say f of I plus 1, if this is the I. This is the distance for the solution I. Okay. So you go for I plus 1, the next solution in ranking. This is for the first one here, minus F1 for the previous one, which is I minus 1. So I'm assuming this are the normalized objectives. Okay. If these are not normalized objectives, then you have to divide by F1 max minus F1 minimum. Maximum and minimum to normalize it. Plus, for the second objective, you do the same. F2 of I plus 1, اللي هو next solution, minus F2 of I minus 1, اللي هو previous one, over F2 max minus F2 minimum. If you have third objective, you do the same. F3 of I plus 1, next solution, minus F3 I minus 1, your previous solution in the ranking, and then you divide here by F3 max minus F3 minimum. So you calculate the distance in the first objective plus the distance in the second objective plus the distance in the third objective. Is it clear? Is it clear يا شباب؟
Yes, sir.
Okay. Step number 5, the overall crowding distance value is calculated as the sum of individual distances, as you can have here, corresponding to each objective. And in implementation, you can have n solutions in a certain k front, in a certain front. You have n objective here. And these are the objective values for each solution are given as such. As just we have explained here. Set all the crowding distances equal to 0, and then you can rank according to the first objective. And this is the vector that we have here, 1, 2, 3, 4, 5, 6. This is the vector here V for the first objective. And then you assign a large value, the first or extreme solutions, the first entry and the last entry of the vector here. These are the extreme solutions will be given infinity. And for all other intermediate solutions, you will calculate the distance as such. Distance equal to the existing distance, then we will add from one objective to another. So starting with 0 here, and this is the fj of I plus 1 minus fj of I minus 1 over f max minus f minimum to normalize. And then you go to the second objective. So this will be, for the first one, will be stored here. And you assume that this is I minus 1, I plus 1, and this is I minus 1. If you want to get the, and you repeat this for the next objective and so on. So example, assume that we need to calculate the sharing distance here of this front. So what do you think? Can you tell us what is the distance of 3 and 4? This is the front. Solution number 1, 2, 3, 4, 5. Okay. In terms of objective 1, these are the values, the existing values of the objectives. And this is objective number 2. Solution 1 has f1 equal to this and f2 equal to this. Solution 5 and so on. And assuming this is the representation. Okay, so this is the case. What we will do here,
Sorting.
Sorting according to objective 1 and also sorting according to the objective 2. So with the objective 1, sorting, we will start with 6, and then 2, and then 1, and then 5, and then 4. Okay, so in ascending order, and this is also will be in ascending order. And the ranking here will be, our sorting here will start with 4, and then 5, and then 2, then 1, and 2, and 3. So this is the sorting for the objective 1, and this is the sorting for objective number 2. Okay, so we have here solution 3 and 4 will be given definitely. We will start, of course, the distance is equal to 0. For objective 1, D3, D4 equal to 1000. Any dummy value, very high. And then we will start calculating D2, the intermediate solution here. This is we will start with the objective number 1. So we will get D2, then we will get D1, then we will get D5. And when we come here, we calculate D5 and we add this with that one. We calculate D1, so we will add this with this one, and we will add D2 coming from here with the distance calculated here. So D2 equal to, if you have D2 equal to what? Equal to what is next? This is 1. What is the objective of 1 and 3? Yani 2D between 1 and 3 here. So let us take the objective number 1 of 1 and 3, and we divide over the maximum minus the minimum to have the normalize the distance. So 1 equal to 6, 1 equal to 10, and 3 equal to 6. So 10 minus 6 over the maximum and the minimum. This is the maximum and this is the minimum. So the distance here equal to 0.444. So this is the first objective. Okay. Then you can go to D1. Then you can go to D5. And then you can go to this. Of course, Tawan, you can do it once. Yani this is D2 here. And you can also calculate D2 here. Yani in addition to this, you can add F2 maximum. What is F2 maximum here? 70 minus F2 minimum, which is 35. Right. This is F2. This is the distance D2. What is next? 3. What is before? 1. Look at the 3 and 1 here for the objective number 2. So 70 minus 50. So this gives you the distance here, which will be added to this one. And you can do it in one step. Or you can finish objective 1 and then you can start with objective 2. Whatever, yani. Okay, so this is D1 calculated here for the first objective and D5 for the first objective, 4 and 1. So this is 4 and 1, 15 minus 10 over maximum minus minimum. So this is the D for the intermediate solution. And then we'll go for objective number 2. The objective number 2 ranking is 5, 1, 2, 4 and 3 will be given high value. فخلاص it's already there. D5, which is the this solution or this distance from the first objective, we will add to it. This is 5. So we have here the next one is 1 and 4. Look at the second objective. Where is 1 and 4? This is 1 and this is 4. So 50 minus 35 over the maximum, which is 70, minus the minimum, which is 35. So this is the total distance, crowding distance of solution number 5. And then we go to the other solution, number 1 between 2 and 5. We will select here what is 2 and what is 5. So 60 minus 42 over maximum minimum, then this is constant. And then D2, again, 2 between 3 and 1. So 3 and 1, so you have 70 and you have 42. Where is 1? 50. 70 and 50, so 70 minus 50 over 71. So this is the, you add them up to with the previous distances. So this is D5, D1, and D2. So it seems here D1 has a higher distance. So if we want to differentiate among these, we will rank them as 1, the best one, and then number 2, and then number 5. Okay? Is it clear?
Yes.
Okay, great. According to the crowded distance, the selection order is 3 and 4, for sure. We will select 3 and 4, and then we will select 1, and we will select 2, second best, and then at the end we will select 5. So if we need 4 solutions, we will take those. If we need 3 solutions, if we need 2 solutions, we will select 3 and 4 only. So this is the Euclidean distance. Here it is. If you can visualize it here, you can easily identify which one is the best, or if you plot it as such, so you can do it graphically. And for the solution number F, for example, with excluding the A and E will be selected anyway. Distance is very high. But solution F, for example, you have distance between this one and this one is calculated as 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So this is 10. Distance here is 10 for F. For D, between the next and the previous, so we have 1, 2, 3, 4.5, 1, 2, 3, 3 plus 4.5. So this will be 7.5. Graphically, you can do it if you have such, scale. C equal to 1, 2, 2.2, مثلا, for example, 1, 2, 3, 4, 2.2 يبقى 6.4. 6.2. For B, you have 1.5, 1, 2, 3, 4, 5, 5 plus 1.5, يبقى 6.5. Okay? Is it clear? So this is the distance, crowding distance of these solutions. طبعا assuming in F1 and F2 are the normalized functions. Nasser, do you have a question, Nasser? Please.
No, that was my question about normalization. Okay.
When you add any distances, you have to normalize. Okay? We cannot say, مثلا, if this is the scale 100, 200, 300. This is, of course, 1500, 1600, and so on. And this is, for example, 0.1, 0.2, 0.3, 0.4. This is, of course, is not the case. Now we need to normalize first. When you add a distance, when you calculate a distance, and you have here dij equal to square root of j1 square plus j2 square, these should be normalized. We cannot add, objectives with different order. So all these should be normalized. And this F1 should be normalized first. And as I mentioned, then I just add 1, 2, 3, 4. Each one is, same. So this should be normalized, of course. Any question? A and E, طبعا. You have F. You have D, 7.5. You have C, and you have B. Why? C and B are not as we have here. So let us check it again. C is 1, 2, 3, 4, 5, 6, 6.2. Okay. For B, 1.5. This is 1.5. Almost 1.5. 1, 2, 3, 4, 5. 1.5 and 6.5. Am I right?
Yes.
So this should be B and C. طبعا if our calculation is is accurate enough. يعني this is 6.2 and so on. Okay. Okay, so this is the crowding distance. The algorithm now, how can we proceed now? Are we going to do ranking for all the solutions? Are we going to do crowding distance for all the solutions or not? So let us see the answers here of this question. Initially, you have a random population. The population is sorted into different non-dominated levels. Is it similar to the first case? Is it similar to sort the population to different non-dominated levels, different fronts?
Yes.
Yes. But we will see now, and we can stop somewhere without completing the ranking of all the population. And we will not complete the whole population. We will stop at a certain front. So this will start similar to the NSGA, but we will not complete all the population. And we will see now where we stop here. Each solution is assigned a fitness equal to its non-dominated level, where level 1 is the best level. Definitely level 1 is the best level, or front number 1 is the best front. Binary tournament, recombination, mutation operators are used to create offspring. Of course, you have, parents in the population, all the population, and you do crossover mutation and so on. So you can have the Q here. Okay, so combine parent and offspring. When you combine parent or the old population with the offspring, and you have N here and N here, so now you have a population of N2N solutions. And you combine the parents with population as well together. Is it clear?
No. Could you repeat?
You have the population 50 solution. And you do crossover mutation and so on, and you create an offspring. اللي هي Q. برضه Q دي فيها 50 ايه؟ فيها 50 solution. In NSGA2, we will combine both. We will merge this with this. يعني we will create B and the Q together. So we have here 100 solution now. اللي هي البيرنتس والاوفسبرينج، parents والchildren كله مع بعض. So we combine them here. So we have 2 N solutions. Is it clear?
Yes, okay. And then this is mean I will have to do the rank everything again.
Yes. هو طبعا this was the initial population. يعني here يعني خلينا let us to be precise. And this, when we have this ranking here, we do ranking for the initial population. Initial population. Is it clear? We do ranking here for the initial population. But when we do now, we start looping here. When we do crossover and mutation, so that means when we are start in the looping process. So you create here a number of offspring طبعا equal to the number of population, a population size. So you have B and the Q now, then you can merge B and the Q or 2n solutions now. And then we will do ranking. Perform non-dominated sorting for R, which is the combination of this. R is B union Q. So then you have R, then you can sort B and Q here. Different fronts. You start from front number 1, 2, 3 for the whole population plus the children here. To stop sorting, if the number of solutions in identified fronts exceeds n, we will not complete the ranking process, but we will stop if the number of solutions ranked is greater than n. طبعا هنا you have 2n solutions. And n is 50. n equal to 50. In 100 solution for R size, you will start ranking. Assume that the front one has 25 solutions. The front two, when you rank, these are the non-dominated solution. This is in first front. Second front, you have 10 solutions. The third front, you have 7 solutions. How many solutions ranked now? 42. The fourth front, so we will continue. Front number 4, we have, for example, 15 solutions. In front number 4. How many solutions? Now it becomes 57. Now it becomes greater than n. So we will stop here. We will not continue. So we have now 4 fronts. Is it clear? Am I clear in this?
Yes.
Okay. طيب, we will stop here and we will do the following. These are the best solution in the population. And this is the next, and this is the third best, and this is the fourth best. Definitely the other solutions are worse than those. So here we will implement the elitism. The first front, second front, third front, we have 42 solutions. So these solutions will be covered to the new population. B at iteration I+1. So this 42 solutions will be directly covered here. Is it clear? So the remaining 8 solutions will be selected from the 15 solutions. This is the 15 solutions in the fourth front. We need to select 8 of these 15 solutions to complete the population before starting again crossover and mutation and create another offspring here. So we implement elitism here by copying directly these solutions in the population here, in the next population, in the new population. But these are 42 only. So we need to select 8 from those. How to select? You implement crowding distance. You do crowding distance for these 15 solutions. The 2 extreme will be given infinity. The intermediate, you measure the distance and you can rank them and you can select the 8 solutions which comes out of 15 here to complete this population before starting again selection and the crossover and the mutation. Salim, yes, you have a question, Salim?
Yeah, Professor. So what's the basis for doing the elitism? I mean, why do we do it from front 1, 2, and 3? what's the idea behind this?
What the idea behind?
Yeah, I mean, why do we select 42 solutions out of 50, for example, here?
لا ما هو this is the first front. يعني here this is the population. This is the first front, second front, third front, fourth front, fifth, and so on. As we mentioned, we have here 25 solutions. You have here 10 solutions.
Yeah.
You have here 7 solutions. These are the best solutions so far, right?
Yeah.
Here you have 15 solutions. These are worse solution, and even we are not ranking them in SGA2. We don't need to rank them. خلاص. These solutions becomes now 57. 57 solutions. Okay? So we will copy directly, and the 25 are the best. This is the second best. These are best solution in the population. 42 solutions though are the best solutions in the population. Am I right?
Yeah.
طيب يبقى we covered 42, so we need other 8 to complete the population. So these 8 solutions, the remaining 8 solutions will be selected out of 15 based on the crowding distance. So you do crowding distance only in this front, only to select 8 solutions out of 15 to complete the population, and then you do crossover and mutation. Then you have Q again, you combine Q and B, you do ranking until you exceed N, you stop. Last front, here you do sharing or crowding distance calculation to complete the population.
So is it always applicable to do the crowding distance criteria for the last front?
Only for the last front, only.
Okay.
So we will not do crowding distance for this or this or this. All the solutions here will be just covered to the population, to the new population. We will do only crowding distance in the last front, where the number of solutions ranked becomes greater than N.
Okay. Okay.
Okay, so Nasser Hakami, your
Yes,
question.
Doctor, I have two questions, Doctor.
Okay.
In step 3, since we are going to make a parent and the children, and then we have to make rank, why you are in the beginning for the 51 we are making a fitness and arranging these levels? Again, we are combining with other, and we are getting another 100, the total. So
Again.
it's step number 3, Doctor. Yeah.
Step number 3. Yes.
This one, do we make do we do a ranking in this one?
Yes. Yes. The population is sorted.
Why we sorted, and then I am doing later on a new population at all? So this is step for me. I don't see any benefit until now.
طيب, let me draw a line here. واقول لك ان this initial population, and we start looping from here. And when we finish all the states and we go to the next generation, we will come here. This is the loop. So this is done only for the initial population, and this is what we have. We didn't apply yet the crossover and the mutation. We don't have offspring. So we will do ranking for the whole population, and we will assign a dummy fitness for the first front, second front, and so on. So when you do selection, you will select from the initial population, and you need to rank the solutions in the initial population. Is it clear?
No, still not clear, Doctor. If I have 3 level in the 50, for example, the 51s.
Okay.
3 ranks, and then when I do a mutation, I do it, for example, randomly or the crossover. So it does not matter. I don't see any link.
Just second.
Yeah, okay.
First front, second front, third front.
For 50 solution.
Yeah, 50 solution, okay.
Okay.
20 مثلا 20 or 15 and 15 مثلا, for example. So what do you want to say? 20 solution, 15 solution, solution.
I said if either I do hairs ranking or not, again I'm getting another 50, and this 50 maybe I have something is better, so I'm doing the rearrangement again from the beginning when I'm doing the step 4 and 5 and 6.
When you want to do offspring, when you do selection, you will select based on what?
Randomly.
يعني لا randomly ما ينفعش, ما احنا قلنا بقى مش random, انا ما بنسكتش random. احنا you select two solutions and you compare them and you select the better as the first parent. Am I right?
So if I'm making the offspring, it's better to make it between one from the first rank and one from the second rank?
Yes. لا يعني again, what is your question? You have 50 solutions and you select randomly. You select solution number 5 and solution number 33. Where is 5 and 33 here? We don't know. If this is the 5 and if this is the 33, so you will select 5. Am I right?
Yeah, that's what I mean. So I'm selecting randomly. There is no relation between.
You select randomly, but you select the better for the as a parent for crossover later. And then you select randomly two solutions and you compare them according to the dominance here, and you say no, 5 is better than 33. So I will take 5 as the first parent. And then I will repeat this again and select the second parent. Is it clear?
Yes, now clear.
Okay.
I have another question.
Yes.
It's too basic from the previous lectures. If we have the 50 solution, and from the beginning I know the one with the on the left, it is the best solution because it's non-dominated one. Why we are again looking to get another level and third level and fourth level like that? Why not only to concentrate only in one levels after mutation and in step number 7? Yes. Why I'm just selecting the 50? Why not just concentrate on the 25 in the first one, the front one? That's all.
Yani we need to concentrate only in 20.
No, I'm doing after mutation. That because I'm getting something with more features with the yes in this one.
Yeah, here you concentrate only in 25.
Yeah, because this is a compromise like generic algorithm, and we already finished getting the best solutions, and I'm getting the non-dominant because it will be the best of the multi-objectives.
If you go back to genetic algorithm, you have best solution. Can you concentrate only on the best solution to generate the offspring? Or you allow also for maybe moderate or intermediate solutions to do crossover and mutation? Hopefully, they have some features that could dominate later on. Are we concentrating on the best solution to
we allow
children, or we allow?
We allow. It is better to allow. This is what I said in number 6. We already allow this one. So this step I already, here, doctor, in this graph, the 25 already we did the mutation, already we did the mixing, already we rank it.
This is represent the best solution. This is the best solution. Are you want to concentrate only on the best solution and discard all the solutions here? And you need only this solution to create the offsprings? You select from those only?
This is step, yes, for me. I think so.
يبقى انت most likely this will degrade your research capability. As if you have the best solution in single objective and you concentrate on best objective and best solution to generate the offsprings.
No, doctors, already we make the combination and mutation, the crossover in step number 4 and 5 and 6. Now I am in step 6, so I can just go directly to the best solution with respect to the F1 and F2. From that one, I can get the best combination of the two.
طيب خلاص, this is in generation number 1. What about generation number 2? What about generation number 2?
So then we have,
4, 5, 6, 7, 8, 9.
so then we have to set a criteria for stopping here also, similar to the.
Definitely. And
Okay.
you have to say, no, I will carry out 1,000th generation.
I got the missing link now. Okay, doctor.
Okay. Maybe
Thank you.
clear in the steps. So it should be written here, and no, we calculate the crowding distance and select. But of course, we have to do stopping criteria if it is met. Otherwise, you go back to, as I mentioned here, this is the initial population and this is the looping here. You go to step 4 and continue until the stopping criteria is met. Time is over. Fill the new population B with the selected solutions along with those ranked in earlier fronts. يعني كل الفرونتس اللي قبلها we will take it as it is and we will do crowding and we select 8 out of 15 in our example. If no stopping criteria met, go back to step number 4. Do another generation and so on. Okay, this is a graphical representation of the looping process. You have here the parents. I'm sorry, I will take just 2 minutes to finish already. Now we have 15 minutes. ما قلتلناش انت يا ناصر ان التايم از اوفر. خلاص
understand.
تعتبر الريفري بتاعنا. احنا كده في وقت ضايع، احنا كده اكسترا تايم كده. So
another timer for me.
So this is the parent, and we do crossover mutation selection. These are the offspring, and then we go to the ranking: first front, second front, third front. In the third front, we have the number of solutions is greater than n. So we'll go back to this front only, and we select based on the crowding. All these are rejected, and this part we rank them according to the crowding distance, and we take those that complete the parent of the iteration or generation T+1, and then we repeat this. And this will go back here, and we will fill Q, ranking this front, whatever. We should do crowding distance and select and so on. So this is the Muhammad Tahir. Please, if you have a question, Muhammad.
Yes, very small question. If the remaining solution is 1 and I have like the 2 extreme, which one shall I select? Or does not matter?
Yeah, of course, you can select any.
Okay.
You can select any, of course. So, any other question? If there is no question, sorry again for the extra time. If there is no question, so please you can leave. Have a nice weekend.